Okay, this lesson is the first actual fully year 10 stuff that you've done. Everything that we did just previously should have been a revision from what you've done in at least year 9, but some of it was year 8 as well. This is first actual new content. So I hope that if you've been doing the practice, you have been able to solve equations with one variable. How would I solve this? Take the 3, good. So 2x equals 4. What do I get rid of now?
You divide there.
Good. Divide both sides by 2. So x is going to be 2. You can do that if you've been practicing. However, when there are 2 variables, if you do what I've taught you so far, you're going to get stuck with your current knowledge. If my question was x plus y, what could I do? Could I get rid of the y? What's the opposite of adding y to something?
Subtracting y.
So I've got x is equal to 9, take y. Am I any closer to working out anything?
No.
Because there's 2 things that I don't know. Alright? But if we have another equation that relates to the same variables, we can actually solve this. When multiple equations refer to the same variables, they're called simultaneous equations. Can someone give me a term? What does simultaneous mean, just in general? Yes?
Like at the same time?
At the same time. If I have multiple equations that refer to the same variable at the same time, they're called simultaneous equations. How do we show that they're simultaneous equations? We use these curly brackets. So for example, if I wrote this curly bracket here around these 2 variables, what is that showing? This shows that the x and y in both equations are the same thing. I'm going to give you a couple of minutes to get the blue here, so writing time, and then I'll give you a situation where you can sort of see the application of it. Although it's kind of weird that Tobias is sitting outside the canteen watching his friends buy pies and sandwiches. But we'll use that as a couple of minutes. If it doesn't need to look perfect, if you just have, it doesn't need to be perfect. How else would I accept that? Maybe you could do 2 brackets and then do a little kink in it. I'll accept that. So the plan for science again Fridays, like I said, we try to be a bit cruisier at it, more revision of stuff. And then Wednesday, the plan is for another set of practicals to do. Let's do the example situation to show how this is applicable. Tobias doesn't know the canteen prices, but sees his friends. The first friend, Alexandra, buys 1 pie and 1 sandwich for $9 altogether. So do you know how much a pie is by itself? Do you know how much a sandwich is by itself? You just know together, 1 of each is $9. Ari buys 2 pies and 4 sandwiches for $24 altogether. He's hungry. Hungry, that one. If x is equal to the price of the pies and y is equal to the price of the sandwiches, what algebra could I write for Alexandra's purchase? How many pies did Alexandra? Good. You could write this. I'm not going to mark you down for writing 1x plus 1y equals. How much do those? 9. Excellent. Okay, but you told me that's exactly the same. You're not going to be marked down for either. They're exactly the same. What would the algebra for Aria's purchase be? Someone else?
2x plus 4x.
4x or 4y?
4y.
Good. 2x plus 4y equals 24. Let me check with you. In your mind, do these equations both refer to the same x and y? Are we talking about the same pies, same sandwiches?
Yeah.
Therefore, how do I show that equations are simultaneous? What do I draw?
Curly bracket.
Yep, curly bracket. And it would be x plus y equals 9 and 2x plus 4y equals 24. Why is this useful? If I only had this information about Alexandra, I could not solve it. If I only had this information from Arya, I cannot solve it. If I have both, I can solve it. I'll give you some writing time for that. This will take longer, so I'll give you longer. Write time. You all enjoying TLP?
Okay.
It is boring as all hell.
The best thing you'll get out of it is the work experience.
I don't mind it. It's not a last lesson.
Tell me about your strengths.
I'm going to do the VIA character survey for the third time.
That's we've had to do that. We did at a meeting once. My best characteristic was organization.
I don't remember what my best were, but my lowest was zest.
My loss was friendships. And I told you I didn't work.
My lowest was love of learning.
But yeah,
You're going alright. You're going alright.
I have my year 9 something like
Okay. Is anyone still on this board? If I move that to the right a little bit, would you still be able to see it?
Oh, I thought it was gonna be flip.
No.
Oh.
Okay. What I'm showing you today, there's 3 different ways to solve simultaneous equations. The first one is to draw the lines and see where they cross. The problem is I need to review whether you know how to draw lines in slope-intercept form. And has anyone vaguely, one of the students here was telling me that you had heard of general form, but it wasn't handled super well, or maybe you just forgot it. Who else has heard of general form of a line? Okay, that's what I'm going to fix that today. The first way to solve simultaneous equations is graphically. What does that mean? You draw the lines and find where they cross. So the question that we're going to answer is, the example is going to be here. Don't write this yet. I should have written this up before. What was it? X plus y equals 9. 2x plus 4y equals 24. The steps to solve graphically is to draw the line equations on a Cartesian plane. You're going to handle it differently depending on the form of the line. You told me in care group you had heard of y is equal to mx plus c. Did your teacher last year talk about rise over run? No.
Yeah. I guess so.
She looks horrified. I'll fix it now. How would I draw a line that's written in this form? Place a dot at C, and that's going to be the y-intercept. So this isn't part of the example, but let's do a practice of it. Let's say that's the grid. Let's say you were drawing y is equal to 3x take 1. Let's pretend I was drawing that. Does this look like y is equal to mx plus c? Is there a number in front of x here? Is there a take or a plus by itself? Okay, how do I draw that? Place a dot at c. So this is your c here. What is c? It's negative 1. So this is 0. I'm going to go down negative 1. This is the y-intercept. If I've got one dot, is that enough information for me to draw a whole line from it?
No.
I don't know what direction it's going. Where do I get the direction? From the slope. That's why it's called slope-intercept. So now I look at this. This number is 3. Write the slope as a fraction. So what would 3 be if I wrote it as a fraction? 3 over? What's just 3 as a fraction? 3 over? 1. Correct? So what is the slope telling you? The top tells you how far up or down to go, and the bottom tells you how far right to step. So if this is telling me 3, how far up do I go? 3. I'm going to go up by 3. How far right am I going to go? 1. Good. So take these steps from C and place a dot. So this is my starting point. Now I know what direction to go. I go right by 1. How far do I go up according to the fraction? 1, 2, 3. I place a dot there. Is 2 dots enough info for me to draw a line through it? Yeah. So I draw a line through them. That's if it's in that form. So this video will be up for perpetuity if you need to review that. What's new, what was vague for you guys, is the idea of general form. Is this written with y by itself? Is y by itself in this equation? Is it?
No.
No, you've got x and y on one side, so it's not this form. Okay? This is called general form. When you've got something x plus something y is equal to something else. Is this something x?
Yeah.
Is this something y?
Yeah.
Is it equal to something else?
Yeah.
So this is known as general form. How do I draw in general form? You make y equals 0 and solve for x. This is the x-intercept. So I will show you how to do that. Let's draw this. Use the maths. Step 1, make y equal 0. So I'm going to write x plus, what do I make y equal to? 0 equals 9. Solve for x. Well, what's left if I've got x plus 0? What is left on the left-hand side? 9. On the left-hand side? X. So x is equal to 9. What's the B step? Make x equal 0 and solve for y. So what am I going to make x this time? 0 plus y equals 9. What's left over on the left-hand side now? Y. This is the y-intercept. So if I want to draw this, I'll need a ruler. Where's my ruler? There it is. I need to semi-draw it accurately, otherwise the lines aren't going to cross each other, so bear with me for this. Okay, I want to draw this first line. X plus y is equal to 9. We just did these steps. We made y equal 0 and we solved for x. What is x? 9. That is the x-intercept. So where would 9 be along the x-axis? Which direction would I go? Left or right here?
Right.
How many times?
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. 1 dot. Is that enough information to draw a line?
No.
So that's why we did this. We made x equal 0 and we solved for y. That's the y-intercept. So where along the y-axis is 9? Would I go up or would I go down?
Up.
How many times?
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. Is 2 dots enough info to draw a line?
Yeah.
So this line that I just drew is x plus y equals 9. Do I have another line crossing it yet? But I'm going to draw this now. So let's do the maths for this one here, down here. Before, what did we make y equal to? 0. You do the same thing again for this new equation. So you go 2x plus 4 lots of, what are we making y this time? What are we making before? 0. Equals 24. What's 4 times by nothing? 0. So what's going to be left on the left-hand side? 2x. Good. 2x equals 24. What's the 2 doing to x? Doubling. What's the opposite of timesing something by 2? Divide by 2. So x is going to be what? 12. That's my x-intercept. So whereabouts am I going to put my dot for x is equal to 12? Which direction would I go?
Up.
On the x-axis. To the right, how many times?
12.
Good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that enough info to draw a line yet? So before I made y equals 0. What do I need to make 0 this time?
X.
So now 2 lots of nothing plus 4y equals 24. What's 2 lots of nothing?
Nothing.
Nothing. So what's left on the left-hand side?
4y.
Good. 4y equals 24. What's the 4 doing to y?
Timesing.
What's the opposite of timesing by 4?
Divided.
What's going to be left? What's 24 divided by 4? 6. Y equals 6. So, we're on the y-axis now. Which way do I go to put the dot here? Up? How many jumps?
6.
Is that enough info to draw a line?
Yep.
Are those lines going to cross each other?
Yeah.
Yep.
Where is it crossing? How far? Here's the crossover point. How far across is that? 1, 2, 3, 4, 5, 6, comma. How far up is the crossover point?
3.
1, 2, 3. That is the solution. In coordinates, what number comes first? The x or the y?
X.
Good. So x is equal to 6 and y is equal to 3. If I've got time, I'll check it. Is that correct for Alexandra's pies? If I bought one pie at $6 and one sandwich at $3, how much is that going to cost? 9. If Aria buys 2 pies at $6, what's that? 12.
Yeah.
Plus 4 at 3, which is also 12.
Yes.
Is it correct?
Yeah.
Okay. This, you only need to do this like one time in the test, because do you agree that would take a long time?
Yeah.
Okay. All of the other methods I'm going to show you are quicker than that, but you need to be aware of this, because if you do general maths with me, I'm literally going to teach you this again in year 12. Okay. Half of the one topic of the year 12 maths course is this, in general math. Okay? Can you please? That's crazy, but can you get that example down and those rules? And I'm going to leave you alone. When you've got that down, your homework will be, it jumps a bit. It jumps to 15A.1. So your homework now, after you've got that example, 15A.1. Would you have been able to get that if all you knew was x plus y is equal to 9?
No.
Because the pie could have been $1 and the sandwich could have been $8. I don't have anything to confirm that, right? It could have been any variation. But the fact that you have this info, the fact that you had someone else buy more stuff, allowed me to solve it, okay? I know it's hard work, it's lesson 5 on a Friday. We're going to chill a bit more in science, but work as much as you can for me now. Get the example and do 15A.1. Okay. I didn't accidentally say anyone's name, so I'll be able to upload this quickly.